Let us see how we can use CSV file to generate our, I can say, question answering type of task in LLM. So what I did, I downloaded few CSV files and I'll be using one CSV file to generate question answering type of patterns, like question answering type of task using Mistral 7B. And I already uploaded that particular CSV file in my drive. Those who, I mean, I already covered this thing in previous session. Those who didn't understand, those who are not understanding what is this, you can go and watch my previous video. So we are uploading this in our drive, basically any files, external files, so that if we use here in CSV file, like if you go there in Google Colab notebook and if you upload it here in files, it is available here for certain session, like when session is available, when session is not disconnected, that time it is available. After that, what happen, it removes it, it get like wiped out. So that's why we upload it for persistent session, upload it into Google Drive. So I took it like one greenhouse gas, like it's very I can say nav type ka, very simple data CSV data set, downloaded from internet and uploaded here. I'll be using this CSV file for our task. And coming back to this particular part, all this code I already explained in my previous video. You can go and watch it. I'll not explain it again. I'll quickly go there and our main part, like where we'll be using CSV file to do all this question answering type of things, and what we can do it with CSV file to get the proper output. Like there are many other way, like we have in RAG, like many other way you can improve your like outcome. We have seen it like RAG doesn't give, like a retrieval augmented generation doesn't give properly answer when you ask it. It doesn't give relevant answer from vector database where you stored, because of many reasons. So we have many other ways to correct that one. I'll cover that in my next video. So like we are re-ranking, like that. There are many ways we can make it good. Like we can use searching also, like it's like we are doing it semantic similarity type of things. We can do searching also from internet or through any like just type of LLM and get that information and then use it with the vector database outcome and get the proper the way we want it. But let us go to simple CSV file uploading and then using that CSV file to generate our response, question answering response. So as I told like earlier, you can go to, when I mounted, like I already mounted and everything, like running our Mr. 7B LM in my notebook instance. So in my drive, I already uploaded this particular where is that greenhouse gas inventory CSV file, and I'll be using that one. This all code as I told, like I already covered, so I am not going into this one. I presume we have instance of LLM with us, and now we are going to use that LLM for our question answering task based on CSV file. So in LangChain, if you go to LangChain, in LangChain we have it like, and another thing, like somebody requested to create LangChain in-depth video. I am working on that one. It is taking time because I need to edit few things and make it and record it, and it takes time, and with the busy schedule, with my working schedule, it's difficult right now. But in this week I'll be uploading all this LangChain detailed video also, and part by part it will be easy to understand important part. Like you don't need to go to all this part what is there in LangChain. LangChain is bigger, like bulky libraries. You don't need to go to all things to understand. You know few things like all these modules, it will be easy for you to work on that. So in this, like if you go there in modules, if you go there in retrieval, we have it different type of like things here. Like if you see document loaders, in document loader, if you see it here, CSV, file directory, HTML, JSON, Markdown, PDF, and all things are there. We already seen PDF. We can do with the file directory. You can use HTML, you can use JSON, you can use text file also, like somewhere it is there, and you can use that one to get all those things. If you see it here, document loader, it is simple text loader. It is just like give it a location of text file and it will take that one and load it, and you use that one for RAG, like our retrieval augmented generation. we are using CSV file, and CSV file, if you come here, like we have one class CSV loader that is there in CSV loader module. We'll be using that one and giving it file path. You can go directly also, it will be taking it like it is file path. We will see in code. With that, we'll be loading that module and then document, and then using that document for our retrieval task, like our RAG type of task. There are many other ways to do this one. Like if you see it here, you can give it your custom what type of delimiter you are using it, like comma separated or some other thing. What is type of quote character, like okay, in that CSV file you might have a certain text that is having quote, double quote. So what type of this one is there, what is field name, like what all things are there. It is just like customizable. You want to get CSV file with a certain thing, like the way you go into pandas, and those who are from data science, they know like okay, you read CSV from pandas, you can give specific columns, a specific type of information. It is same type of things, you can say it. Even you can use a specific column also. Like what happened, there are 4-5 columns in CSV file and you want to use only single column. Like there might be chances you have maybe ticket data. In the ticket data, it is day wise ticket data, and you want to get the only ticket details part to summarize the ticket details. Like okay, somebody, technicians or anyone goes there and update ticket information, what happened to this thing and what all things are there. So it is like your one detail field is there, and you want that field only to summarize a test summarize, not question answering, like test summarize. So you can use that field only and get that one, load it, and then use that particular data for text summarization type of task, not question answering, because question answering has different stuff into that. You need to retrieve and all those things. This one thing, like I mean, this is important thing, distinction it is there. If you see it, like if you want only single field. So what I'm taking it, like I'm getting it is CSV file, and this CSV file loading it. And this particular function, we have seen it PyPDF also. We use PyPDF loader for PDF loading. Now we are using CSV loader, and using with that we are getting one document. I can say I'm just giving, you can give data, you can give document, whatever it feels good to you. And after that we are creating chunk of this particular document. Like it is uploaded, everything is uploaded right now in your system. Right now you have the data as a complete thing CSV loaded to you. Since you are going to use RAG, Retrieval Augmented Generation, and we are going to store this information into vector database as a chunk, we will be using character text splitter, or you can use a recursive character text splitter also. We will see at the other cell we did recursive character text splitter also. We are giving chunk size and chunk overlap. Important thing to understand, when you are writing a production grade application, you will be facing a lot of challenges in this particular part. I heard from many people, like I got also requests from many people, like it is not giving relevant information. So there are two reasons to not get relevant information from your vector database. First is your maybe data is not chunked properly, it is not given properly to vector database to store it. Second, maybe more reasons, like under reason is main reason, you can say it, okay, your information retrieval is not proper. Like you retrieved that information, that retrieved information is not the relevant information what you wanted, because it may not be chunked properly, and you stored everything, dumped it and stored it, and you try to get information, you get garbage information, sometimes unnecessary information, sometimes no information at all. So this chunk size is important to give you like a capability to store properly in vector database, so that you can get relevant information. So vector database works with semantics similarity. Like if you store certain things, if you query it and it query get converted into vector using embedding model, and that vector is goes there and search it with the semantic similar type of information. If it gets semantic similar many things, it gives you information like garbage information, and it may not be relevant. Sometimes it doesn't find it because your chunk is very small. So chunk size is important in terms of keeping it proper chunk. Like okay, you start with certain chunking, take it like 1000, 2000 or maybe 5000, start reducing it if it is not giving it. If reducing also doesn't give it, start increasing it. Like it may be context is not there in 5000 chunks, 5000 token size. Okay, so that's why like you need to experiment with this particular chunk size to get what you want. This is where your task is when you are not working in proof of concept type of things, where you are using data that is very unstructured data. It may be like log type of data. It may be not a story data. Story data is very easy to do question answering. I mean, you can do question answering very easy, but when you have unstructured data, it's difficult. That time we need to have different strategy. Even I'm just saying it, you should not simply dumping this all information into this particular chunking. You can do pre-processing before getting this data, I mean putting into chunk, and then use that pre-processed data, like you remove unnecessary information, those you don't need at all for question answering, and then use that for chunking and do it. This is where that distinction between working on POC or 10 minute of, like you say, everybody said 10 minute will create QA chatbot. I just say like it took around 2-3 months for us to create one document summarization question answering capability to get the predictable output the way client want, the way people want it. Okay, it's not an easy task. So this all things become important there. And the thing is chunk overlap. Chunk overlap is important to give context. Like suppose you have a certain CSV file where that every row is having connected with another row. It's highly unlikely with CSV file. It's good with PDF file where that maybe you have a story and one para is having, second para is having connected connection with the first para, like that things are there, so that you overlap information, so that few information of first para is available in second para, so that if you go there and do semantic similarity type of search using your retrieval augmented generation, you get the proper response because things are there in both para. So you get the things like, okay, it may be available in second para also, may not be in first para. So you may be getting 3-4 information, and then you filter it topmost what is working for you, the way retrieval augmented generation works. And I explained this thing in my previous video. So chunk overlap is also important. Give it, start experimenting with 20, 100, what works for you, and whether it works at all for you or not. Like suppose in CSV every row is distinct, it doesn't connect it with the previous row, you don't need to give it, simply use this one to get this thing. And we have seen it that after creating this text splitter instance, like we will be splitting document, like this is your document, and then using that, like after that you create one embedding model, like again Hugging Face embedding model we are calling it, and creating instance. So you got this thing like chunk of document, you got embedding model using Hugging Face, and using fast, like I'm using fast, you can use ChromaDB, you can use Pinecone. I just say experiment with anything, but stick with one thing for learning. Later on do it anything what you want it, and if you struck, just experiment, you get answer it. Yeah, maybe we'll be having more vector database to connect here in session later on. I have many things to create videos, so I mean it's difficult for me, but you experiment. So we have it like a fast database from LangChain. We got it like one library internal, like it is fast is, again I told, is Facebook AI similarity search intern in memory vector store. It is not vector database. There is distinction between vector database and vector store. We will just cover this thing in details later on if you are interested only. Otherwise I may be, when we will have some live session, that time I can show it how it works and all those things internally. It's very interesting topic, I like this one. So in this fast we have from document, like which given chunk document, and Hugging Face embedding like our model, basically Hugging Face embedding this particular model what created instance, and we use one of that sentence transformer. So I covered this thing earlier. You can have any type of model what suits to you. There are many models coming, and there are new models also coming, embedding models. There are new other, like I don't want to confuse you, like new things are coming up. I mean last 2-3 days we seen a lot of churns going on particular things. We will just see this one, but don't get confused. Things will be coming, technology will be coming, new things will be coming. If you keep running I mean behind them, it will be very difficult to learn it, and people get demotivated because a lot of things are coming, and they see like I don't know what other things are there. And I feel like we don't need to know everything. You know what works for you, and then you explore more. So we have DB with this chunk doc and Hugging Face embedding. With that DB we are tying using type of similarity that is already covered earlier, and we are getting, suppose uh, top four retrieval. Like if you go and search in vector database, I should get top four. I'll choose whatever fits for me, like top one. Okay, maybe that's what, like you can give top one also, k1 2 and all those things. It is basically for all vector database we have retrieval type and ranking. This is what ranking, that's what concept came, re-ranking. Like if we get rank, again we do re-ranking to get the relevant information, so that we don't get, and challenge with rank system is not getting relevant information. It's very challenging to create predictable and good retrieval augment generated system using all these things. There are many things to take care. We will just see techniques, different techniques later on also. So we have created conversational retrieval chain. That's what I already covered earlier, like using our Mistral LLM and our retriever. This is our retriever, basically our database vector store, and return source document true, like it's fine, like is one parameter, and doing this query. Okay, so I'll just this data is having certain things. Okay, let me open this particular data, click it and just see. So if you see here, like it data has like a country, year, value, and some information, some other thing like category. So like carbon dioxide with Australia and this year. So I'll query it here. What is carbon dioxide? Just some random, even English may not be proper. Okay, son of Australia. Just simple question. Okay, enter. So let it get the output. What you get, you may get no output also, unpredictable output also. That is what, like you need to experiment it more. So I got some information like the carbon dioxide emission of Australia in 2014 was something something. I mean, there are many information it given what is the latest one. So it is up to you how you are going to use that one, and what are the information, how you are creating chunks. Like you want to, because we use loader, it dumps everything and then chunk it, not considering like date range and all those things. It chunks whatever random comes into that one. So let us see, like how can you do it your more controllable way, the way you want it. You want to segregate certain information in certain way so that your years would be in one bunch, and maybe like anything you want to do it. So you can use CSV file with Panda data frame also, like CSV file. I mean, there are many ways. I'm just giving Panda data frame. So pandas, like it is again data science important libraries to do all this manipulation of data and all those things. CSV file, it does a lot of other things also, but take it like you can use pandas data frame, pandas libraries to load read CSV file and do some stuff on top of that. So it is again, it is like having it pip install pandas and doing import pandas as PD and read CSV. This is one command like function where that we are loading CSV file from our drive, and data frame, this become one data frame. Data frame is having like row by row, same thing. CSV file, it will be row by row. If you print it, you will be getting data frame, all those print if you do print df, you will be getting all those things. Now this thing we'll just see why using document. So what I created one text variable here, and looping it this data frame. Like you can loop different way data frame. I am looping it like you get the data frame index, okay, and loop it one by one. If there are 100 rows, it will go by 1 2 3 4 5 6 like that. And while looping it, you are appending this text with this one. Text, if you see, is equal to, and this one plus and is equal to, like appending this text into whatever information is there. Like it has country or area, we have seen it into that field, like it was country and area, and there was year, value, and I didn't do category. Okay, see the magic is like, okay, it gives up information even we didn't give in this one. I am asking carbon dioxide into this one, maybe I'll be asking it. If you see, response will be different. It will give some information, but that may not be relevant to you. So that's why, like if you want category also, you give it like this is the way you get it, like value, like in data frame. If you go to df, give it column name and index name in this bracket, so you will get that particular value of particular row. like it is running one by row, one by one, so you'll be getting this one. Data frame works like that. Okay, pandas data frame. And what I'm doing it here, let me delete this one. Okay, what I'm doing it, I'm appending, if you see, new line and 5 hashes, 1 2 3 4 5 hashes to separate it. Like every row is separated by 5 hashes, so that when we are going to do chunk, we know how to separate this information, how to separate chunk. Okay, and that is important part. Like you can do this chunking strategy the way you want to group information. I just kept it very generic. Like you can give it 5 hashes. I'm just keeping it so that you usually don't get it like 5 hashes in your text. Okay, so it doesn't create it like random type of chunk. So this is just to create separate it out every rows. Okay, this every rows. Now what I'm doing, getting it like text. When you want to use any text splitter, anything, so you can't use it text directly. So you need to convert into documents. So we have seen it my previous video also, like in LangChain we have document class, and with the document class, if you give page content, what is that text, and source local, we are using this local. So you create one documents that is usable into you can say it like text splitter. Now come back here, we are doing same usual stuff. We are using here recursive character text splitter. Okay, instead of using it text splitter, we are using recursive text character splitter, and using this creating chunk size, I'm giving some chunk size same as a 1000. Chunk overlap, I'm not giving anything. And separator, this one, if you see separators I'm giving it hashes. So what happened, if this particular document it is not using default separators, like it does have default separators like this one, /n, I mean 2 in new line, 1 new line, some space, without space, it wherever it find this one, it will create chunk 1000 and it will split. But instead of that, I am giving my own chunking strategy, like my own separators, so that I have control what need to be chunked, how we are grouping it. It looks very simple, but when you go like for working with the certain use cases where you have complex data, where you need to club it together date wise and all those things, it helps a lot. Okay, I can say it will help a lot. So you got chunk doc, and this chunk docs, basically you are I mean from this text documentation, you are getting this particular text splitter, you are getting with the split documents, you are passing it our documents is like you got it, and it should be going, it expects lists. Okay, so we are giving lists. List is your Python list, or any language, like if you go to Java and all those things, like wherever you go, your list list is like your again collection type where you store information. So it expects lists, so that's why we are giving into bracket. And again, this embedding other stuff, we have seen it, how we do it. We have conversation chain. Now we'll go to give same question here, and see, even see, we are not giving category here. Category was there in CSV file. Let us see what it gives. It will take a few seconds since it is running in this one, and it may take few seconds to generate answer. So wait for that one. Even if you don't give it category, it will give some answer. I mean, LLM is notorious because it gives answer. It says no data, that is fine, but if it gives answer, that is the problem. That should not happen. It is taking time. So if you see, like it is given certain things, because category was not there, we are given carbon dioxide here, that was there in category. The data is not itself in this I can say this complete chunk. Okay, but it gives something to calculate something we need to here, which this got CO2 emission, this, and I mean it gives a lot of information to give this information. Like this is correct, like it, you might go there here and find same type of answer here like this, but this is more relevant than this one. Why? Because we miss certain information category, but this is more powerful in terms of segregating things the way you want it, customizing things the way you want to group chunk. So I mean, you can use it pandas, you can use anything, like you can connect with database and get the database information as a text and run it. And important thing is, wherever you're getting data, if you're looping it, that data, like if it's running line by line, if you're looping it line by line, give it some separator with every row, so that same separator, use it for your chunking here, this chunking separators. And try to give separators value, like I found like 5 hashes are good, like we generally don't find 5 hashes in any text. So for good chunking strategy to grouping things, but you can find whatever like good for you, like there may be some special character and all those things. Try to do this one. Certain special characters LLMs may be used internally, and that time it gives I mean some unrecognizable output. That's what we have seen it, like it doesn't gives output properly if you try to use certain special character that is used internally by the LLM. So this is one thing I can say it, like you can utilize it when you are doing RAG with anything like CSV, database, or anywhere. Chunking strategy, you can follow it here and you will be finding it better output. This is where that I can say it, like relevancy, first step of getting relevant data in RAG is checked. There are many stages. We will be covering that one also, like re-ranking and all those things. There are many other strategy, but this is one strategy. If you don't follow it, anything anywhere else you go, you will be getting some issues, some other things, like because your first step is not fine. And before this first step, again say you can say zeroth step is pre-processing of your data. If you find your data is not supposed to be there in vector and that will not help you in question answering, remove that data before getting chunk. Simple, I can say it. And I'm saying this with my experience working with this type of task, where that we struggle a lot and find some solution like that. Okay, thanks.